Well, this is Dr. K. Shirish Kumar working as Associate Professor of Chemistry, St. Peter's Engineering College. So today I'm going to explain you about internal treatment or internal conditioning method. Now, before I dive into this internal treatment or internal conditioning, first and foremost, let us discuss what is internal treatment or internal conditioning. Internal treatment or internal conditioning method involves removal of scale forming substances from the boiler fed water. That is, whatever the water which has been fed inside the boiler for the production of steam, after passing that water inside the boiler, we are going to remove the scale forming substances from the water. Now, this particular method mainly targets the scale forming substances. Now, as this method is done after passing the water, after feeding the water inside the boiler, this particular method or process is called as internal, as it is done internally, right? So we are removing the scale forming substances after passing the water inside the boiler. After passing the water inside the boiler, we are removing the scale forming substances. So since we are removing the scale forming substances from inside the boiler, that's the reason it is called as internal treatment or internal conditioning. Now, how to do this internal treatment or internal conditioning method, right? Now, basically we have three conditioning methods by which we can remove the scale forming substances from the boiler fed water. The one is colloidal conditioning, the second one is phosphate conditioning, and third one is Calgan conditioning. The first and foremost, let us discuss the colloidal conditioning. Now, what do you mean by colloidal conditioning? The name itself is self-explanatory. The colloidal conditioning involves the removal of the scale forming substances, making use of colloidal substances. Colloidal substances means what? Gummy substances. Colloidal substances. Now, the examples of the colloidal substances which are used during the colloidal conditioning in order to remove the scale forming substances from the boiler fed water includes agar-agar gel, gelatin, and kerosene. So these are the colloidal substances which are used to remove the scale forming substances from the boiler fed water. Now I am going to illustrate the boiler. Now let us say that the circle is the boiler. The circle is the boiler. And this white portion is the water, and we are heating the water. Whenever we are heating the water, whatever the scale forming substances are present inside the water will gets they gets precipitated as the scales. They gets precipitated as the scales, and these scales are non-adherent precipitates. These are adherent precipitates means what? They are sticky in nature. Since they are sticky in nature, they gets stick to the inner walls of the boiler firmly. They will stick to the inner walls of the boiler very firmly. Now, whatever the scales which are sticking firmly to the inner walls of the boiler, now this agar-agar gel or gelatin or the kerosene, whenever they're added, they will get coated on the surface of the scales. They get coated on the surface of the scales. Once they get coated on the surface of the scales, they converts a sticky precipitate, that is adherent precipitate, into non-adherent precipitate, that is non-sticky precipitate. That is, the scales are going to be converted into the sludges. The scales are going to be converted from scales to the sludges. Now the sludges, as they are loose and non-adherent precipitates, they get suspended in the water. They get suspended in the water. Now, with the help of the blowdown operation involves exertion of the pressure on the water which is concentrated with the sludges. We have to exert the pressure on the sludges now. When we exert the pressure on the sludges now, we can dispose that sludges outside. So with the help of blowdown operation, whatever the scales which has been converted into the sludges can be disposed out. This is about the colloidal conditioning or colloidal treatment. This particular treatment involves the addition of colloidal conditioning agents such as agar-agar gel, gelatin, and kerosene. Now what they are doing? They are coating over the surface of the scales and they are converting the sticky nature of the scales into the non-sticky nature. Once the sticky nature of the scales have been converted into the non-sticky nature, they will be converted from scales to the sludges. Now the sludges are non-sticky, non-adherent precipitates. Since they are non-adherent precipitates, they get suspended inside the water. Now with the help of blowdown operation involves exertion of pressure on the water which is concentrated with the sludges. When we exert the pressure on the water which is concentrated with the sludges, now the sludges are disposed out. Now this is how we can remove the scale forming substances from the boiler fed water, making use of colloidal conditioning. Now let us discuss how, making use of the phosphate conditioning, we are going to remove the scale forming substances from the water. Now let us discuss about phosphate conditioning, right? Now phosphate conditioning, the name itself is self-explanatory. What do you mean by phosphate conditioning? Phosphate conditioning involves the removal of scale forming substances from the water, making use of the phosphate salts. Now what is that phosphate salt which is widely used for removing the scale forming substances from the boiler fed water? The major phosphate salt which is responsible for the removal of the scale forming substances from the water is sodium phosphate. Sodium phosphate. Now there is no need to remember, there is no need to buttify the molecular formula of the sodium phosphate. Now in the sodium phosphate, what is the cation? Sodium phosphate, cation is sodium. Cation is sodium. Cation is sodium. Now Na. And what is the anion? Anion is phosphate. Phosphate, PO4. PO4, right? Phosphate. Now what is the valence of cation? Na plus 1. What is the valence of phosphate? Anion, PO4 minus 3. Now this 3 becomes subscript for the cation. This 1 becomes subscript for the anion. 1 becomes subscript for the anion. Accordingly, sodium phosphate is Na3PO4. Na3PO4. So Na3PO4 is the sodium phosphate. This is how you have to get the molecular formula of the molecule. Don't buttify. So first of all, you have to identify what is the cation in it, what is the anion in it. Now what is the cation in it? Sodium is the cation. And what is the anion in it? PO4, that is phosphate, is the anion. Now what is the valency of the cation? Plus 1. What is the valency of the anion? Minus 3. Now whatever the 3 is here becomes subscript for the cation. Whatever the 1 is there for the cation becomes subscript for the anion. And while converting the superscript into the subscript, we need not to consider the charges. So this is how you have to write the molecular formula. Don't buttify it. Now this sodium phosphate, which is the phosphate salt which is used during the phosphate conditioning, mainly focuses or reacts with the major scale forming substance present in the boiler fed water. Now the main scale forming substance present in the boiler fed water is calcium sulfate. Now once again, calcium sulfate, there is no need to buttify the molecular formula of this molecule. Calcium sulfate, what is the calcium sulfate? What is the cation? Ca. Calcium is the cation. What is the anion? Sulfate is the anion, SO4. Now what is the valence of the cation? Plus 2. What is the valence of the anion? Minus 2. Minus 2. Now this 2 becomes subscript for this. Now this 2 becomes subscript for this. Now what you are going to get? Ca2SO4 taken 2. 2 both are same. So it will be CaSO4. Now there should not be any ambiguity or confusion. What is the molecular formula of calcium sulfate? Molecular formula of calcium sulfate is calcium CaSO4. CaSO4. Now let us discuss the reaction involved in this. Now what is one of the chemical in this? Sodium phosphate is being used as the phosphate conditioning agent in this particular phosphate conditioning. What is the sodium phosphate? Na3PO4. Na3PO4. Now it is targeting the main scale forming substance. What is the main scale forming substance? Calcium sulfate. CaSO4. 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 Now the toughest part is how many moles of sodium phosphate is reacting with calcium sulfate, and how many moles of calcium sulfate is reacting with the sodium phosphate. Sodium phosphate. Now it is SO4 minus 2, no? This is SO4 minus 2. Now put this 2 in front of sodium phosphate, just for remembering purpose I am saying. Next it is PO4 minus 3, isn't it? Right? It is PO4 minus 3. Now put this 3 in front of calcium sulfate. This is how you can remember. SO4 minus 2, put this 2 in front of sodium phosphate, and PO4 minus 3, put this 3 in front of calcium sulfate. Now what are you going to get? The reaction is all about the combination of the cation of one molecule with anion of another molecule, anion of one molecule with cation of another molecule. Now what is the cation present in this? Sodium is a cation present in this, and PO4 minus anion. And what is the cation present in calcium sulfate? Ca plus 2, right? Calcium, Ca. And what is the anion? SO4. SO4 is the anion. Now the reaction is all about the combination of the cation of one molecule with anion of another molecule. Now what is the cation here? Na is the cation in this, and SO4 is the anion in this. And what is the anion in this? PO4 is the anion in this, and Ca is the cation present. Now what you are going to get? CaPO4. CaPO4. But CaPO4 doesn't exist. Calcium phosphate is, this CaPO4 leads to the calcium phosphate. But what is the formula for calcium phosphate? Now what is the formula for calcium phosphate? Already I have discussed that. What do you need to do? You have to write what is the cation. What is the cation? Calcium is the cation. And what is the anion? Phosphate is the anion, PO4. And what is the valence of cation? Plus 2. What is the valency of anion? Minus 3. Now what you are going to get? Ca, this 3 comes here. Now 2 goes here. Now you are going to get Ca3PO4 taken twice. Ca3PO4 taken twice. So you are going to get Ca3PO4 taken twice as one of the product. And what is left? Na is left in this, which is the cation, and SO4 is left in this anion. Now what accordingly what you are going to get? NaSO4, that is sodium sulfate. Now what is the formula of sodium sulfate? What is the cation? Na. And what is the anion? SO4. Now what is the valency of sodium? Plus 1. What is the valency of sulfate? Minus 2. So 2 comes here, 1 goes here. So it will be Na2SO4. Na2SO4. Now the next product is the combination of Na and SO4. The combination of Na and SO4 is Na2SO4. Na2SO4. How many moles? How many are there? Totally 6 are there. So 3 here. 3 into 2, 6. So right. So this is how we can write the molecular formula of the molecules, and this is how the products are going to be obtained when sodium phosphate conditioning agent is reacting with the calcium sulfate, which is the main scale forming substance. Now the main scale forming substance during the phosphate conditioning is converted into the sludge. Right? Now sludge is being formed, that is in both the cases, in the colloidal conditioning as well as in the phosphate conditioning, the scales are converted into the sludges. Now the sludge disposal is not possible under all circumstances. Now whatever the sludges which are going to be obtained during the colloidal conditioning and the phosphate conditioning, their disposal is not possible easily under all circumstances. Now what we are supposed to do, we have to go with another method which is ideal, which is not converting the scales into the sludges. Instead it is converting the scales to some other substance. So just remember that colloidal conditioning and phosphate conditioning are not considered to be the ideal internal treatment methods, because they are going to convert the scales into the sludges, and the sludge disposal is a huge problem. So that's the reason we have another type of internal treatment method, which is Calgon conditioning. Calgon conditioning. This is ideal. So it is not going to convert the scales into the sludges, unlike the phosphate conditioning and colloidal conditioning. What it does, we are going to discuss now. Now, before going to see what is Calgon conditioning, first and foremost, we have to discuss what is Calgon. Before that, what is Calgon conditioning? The conditioning involves, it is the internal treatment method which involves the addition of Calgon to the water. Addition of Calgon to the water. Now, what is Calgon? Calgon, what is Calgon? Calgon is Na2, Na4, PO3 taken 6. This is the Calgon, which is the chemical name of Calgon is sodium hexa metaphosphate. Sodium hexa metaphosphate. This is the Calgon. Now, whenever the Calgon is introduced into the water during the Calgon conditioning, what happens? This Calgon initially undergo ionization or dissociation in the water. Na2, Na4, PO3 taken 6. Initially, it will undergo dissociation or ionization into, so how many NAs are there? 2 NAs. So, 2 Na plus 1 plus, what is there here? There is no need to remember, multiply. What is there here? Na4 is there, Na4 is there, and next PO3 taken 6, and it will be obviously minus, because this is cation, obviously it will be the anion. Now, how many moles or what is the charge on this anion, whether it is -1 or -2? So, how many cations are there? +1 is there, right? +1 is there. But how many +1s are there? 2 are there. +1 into 2 +2, right? 2 are there. So, that's the reason if it is +2, it will be -2. It will be -2. This is how you can remember. Just for remembering purpose, I am saying. If it is +1 and +1, how many +1 such +1s are there? 2 are there. So, that's the reason it is -2. -2. Just remember like this. Now, this is the highly reactive anion. This is highly reactive anion. Now, highly reactive anion Na4 PO3 taken 6. It is highly reactive anion which has been released inside the boiler fed water, targets the main scale forming substance. Now, what is the main scale forming substance? Calcium sulfate. Reacts with calcium sulfate. Now, how many moles? That is a big question. So, just for remembering purpose only I am saying. So, here there is a 2, right? Now, here there is a 2. Now, put the 2 here in front of this, right? In front of this. Now, what happens? Now, what happens? So, this won't be the reversible. It won't be reversible, right? Now, what happens? Now, Na4 is there, right? In this complex, there is Na4. Now, Na4 is replaced with how many calciums are there? Ca2, right? So, Ca2, instead of Na4, Ca2, the remaining is as usual, PO3 taken 6, 2 minus plus, what is left? Na is left, which is cation, and SO4 is left, which is anion. Now, NaSO4 is not possible. Already I have discussed. Na, if combines with SO4, it will be Na2SO4. Already I have discussed in the previous case. So, it will be Na2SO4. Now, how many moles? How many moles? How many sodiums are there? 4 are there. So, if we put the 2 here, it will be Na2SO4. Now, this is the most soluble complex. Most soluble complex. Now, during this Calgon conditioning, instead of the scale conversion into the sludge, in the previous cases, the scales have been converted into the sludges and the sludge disposal was a huge problem. But here, what happened is the scale is converted into most soluble complex. It is converted into most soluble complex. Right. Now, what happens? Basically, when the scale forming substance will be thrown onto the inner walls of the boiler as adherent precipitates, sticky precipitates. when the solubility, what we are doing, we are taking the boiler, inside it we are feeding with the water and we are heating it. Now whenever we are heating it, whatever the scale forming substances are present inside the boiler, their solubility will be decreased. Once the solubility is decreased, they are thrown onto the inner walls of the boiler as a adherent precipitate, which are the scales, right, when their solubility is decreased. But here what it does is, it is converting the scale into the most soluble complex. Since it is converting the scales into the most soluble complex, this most soluble complex means what? It will be miscible with the water. It never ever comes out. Whenever it is never ever coming out, then it never ever will be thrown onto the inner walls of the boiler as the adherent precipitate, which are the scales. So this is how, by converting the scales into the most soluble complex, the colloidal conditioning, that is Calgon conditioning, will never allow the formation of the scales which gets accumulated on the surface or inner walls of the boiler. So the technology is different from the phosphate conditioning and colloidal conditioning, right? And do remember that colloidal conditioning and colloidal conditioning and Calgon conditioning are used in low pressure boilers, whereas phosphate conditioning is used in high pressure boilers. That is the difference. Now, to put in a nutshell, that is to synopsize, just to remember that colloidal conditioning, phosphate conditioning and Calgon conditioning, all these three conditioning methods removes the scale forming substances from the boiler fed water. But this colloidal conditioning and phosphate conditioning are converting the scale forming substances into the sludges, and sludge disposable is a huge problem. For that reason only, the colloidal conditioning and phosphate conditioning are not considered to be the ideal methods of internal treatment, ideal methods of removing the scale forming substances. So that's the reason another conditioning is introduced, that is Calgon conditioning. Now this Calgon conditioning, instead of converting the scales into the sludges, it is increasing the solubility of the scale forming substance. Whenever there is an increase in the solubility of scale forming substance, it never ever come out from the water, even though huge amount of heat is being supplied. If it is not coming out from the water, so definitely it will not be thrown onto the inner walls of the boiler as a scales. So this is about internal treatment or internal conditioning methods. So I hope you understood this internal treatment or internal conditioning method. So I will come up with another topic in the next video. Thank you.